In this section, we will learn how to take the derivative of logarithmic functions, but let's do a quick review on what logarithmic functions are. For a greater than 0 and a not equal to 1, the logarithmic function y equals log base a of x has domain x greater than 0, base a, and is defined by a to the y power equals x. So that's an exponential form. If the base is 10, then it is called the common logarithm. If the base is e, then it is called the natural logarithm. Now, these are the most popular types of logarithms to use. And so if you were using the common logarithm, you'd have log base 10 of x like that. However, we use it so much that we just drop the 10. So this is equivalent to log base just log of x like that. So we just drop the 10, and that is known as the common logarithm. And then the natural logarithm is written like ln of x like that, and that is equal to log base e of x like that. But we don't write it like this. We use this notation here. And since this is business calculus, we want to talk about the derivative. So if y equals the natural log of x, then the derivative of that is equal to 1 over x. Now, one quick thing that I would like to talk about before we jump into taking some more derivatives is sometimes people don't know what the number e is, and it's an irrational number kind of like pi, and it's equivalent, or it's approximately equal to 2.71, and it goes on forever, but that's the decimal approximation. And there are several different ways that we can define the number e, but one of the ways is if you were to graph the function y equals 1 over x for x greater than 0, here's the y-axis, here's the x-axis. The graph of that function looks something like that. And let's say you were looking at the function when x equals 1, and then you also wanted to look for a value here like that, such that if you took the area of this green shaded region and you wanted that area to be 1 square unit, then we could move the question mark around kind of like a sliding scale until the area equaled 1, but the number that satisfies it so that the area of that green shaded region is 1 is the number e, and again, it's approximately 2.71. So that is some background on the number e for you. Let's go ahead and jump into examples where we will start taking derivatives. Example 1 wants us to find the derivatives of f of x equals negative 2x minus the natural log of x, and g of x, which is equal to the natural log of x times the square root of x. So f prime of x is going to equal negative 2 minus 1 over x. And you could find a common denominator if you wanted to simplify that, or you could just leave it like that. And then g prime of x, we would need to use the product rule. So we're going to have the first times the derivative of the second plus the second times the derivative of the first. And we can clean that up a little bit. So that's going to be the natural log of x over 2 root x plus the square root of x over x like that. And you can find a common denominator again, but let's just leave it like that. One thing that I would like to mention is that, or two things actually. When I write the natural logarithm, note that I use a cursive L and N. And the reason that is sometimes you'll see people write it like this, but this could very much get confused for the number 1. And so there's a lot less confusion if you write it so that it's cursive and it looks like that. The other thing is sometimes you'll see people not put parentheses around the x, and that's a really big pet peeve of mine because if you wrote natural log of x plus 1 like that, it's not very clear if you don't put parentheses whether you mean the natural log of x plus 1 like that or the natural log of x plus 1 like that. And those are two very different things. And so I always recommend to my students, A, that you write your natural log in cursive, and B, use parentheses around your argument. Now, even though I give out this advice, not everyone listens. That's fine, whatever, but it's what I recommend. It's kind of like, you really should wear a seatbelt when you're driving your car. Not everyone does it, but it's really like a best practice. So in the previous example, we saw things where we were taking derivatives of a natural log and inside the function was just x. If you are using functions where they're more complicated than just x, then we have to use chain rule. So if y equals the natural log of u, where u is a differentiable function of x, then the derivative is equal to 1 over u times du dx. Let's see some examples. So example 2 wants us to find the derivatives of f of x, which is equal to the natural log of 4x to the 7th power minus 2x cubed plus 1, and g of x, which is equal to the natural log of 9x minus 3 over negative x. So f prime of x is equal to 1 over this whole thing inside the parentheses represents u, so it's 1 over u times du dx, which is equal to 1 over 4x to the 7th power minus 2x cubed plus 1 times the derivative of u, which is going to be 28x to the 6th power minus 6x squared. And let's see, let's go ahead and combine those into one fraction. So after multiplying, you get 28x to the 6th power minus 6x squared over 4x to the 7th minus 2x cubed plus 1. So that is the derivative of our f function. Let's go ahead and find g prime of x. Here we will need to use the quotient rule. So bottom times the derivative of the top, which is going to be 1 over 9x minus 3, and then we need to use the chain rule and need to multiply that by 9. So bottom times the derivative of the top minus the top times the derivative of the bottom, which is going to be negative 1, all over the bottom squared. So that's going to give us that. Okay, so let's do some simplification. Let's see, we will have negative 9x over 9x minus 3, and then this minus and this minus will change into a plus. So we'll have plus the natural log of 9x minus 3 all over x squared. Not the prettiest, but we'll deal with it.